Covariance and correlation. Let's understand covariance first. So what is covariance? In generally speaking, a covariance and correlation are related to each other. Let's understand one by one. So if I talk about covariance, it is a method to find the variance between two variables. Two variables, say that X and Y. Or maybe I can say that age and experience. Right? You can say, you can take any variables. Right? So the variance between two variables. This is one variable and this is another variable. And we are trying to find the variance between two variables like age and experience. All right. So variance, this will have a data. This will also have a data. We are trying to make use of these two variables and find the variance. So basically we are trying to understand how much one variable is going to differ based on the other variable. Right. So that's how we can interpret. Now let's understand. It is the relationship between a pair of random variables where a change in one variable causes change in another variable. It means that, suppose say age, let me take out all this and I will say age and experience. These are two variables, variable 1, variable 2. Age, suppose say 25 and 30, 32. I say experience 4 years, here are 9 years, and here 11 years. So basically what this point says, it is a relationship between pair of random variables. Say age is one variable and experience is one variable. I have taken randomly, where a change in one variable, suppose a change in one variable, causes change in another variable. If you think in general, as and when my age is going to increase, my experience is also going to increase, right? My experience is depending on age, or I would say it is not depending on age. Basically, as and when age, you are getting older and older, your experience also going to increase. So the variance between this variable and this variable, which is a pair of two variables, is what I'm going to find. So how much is going to increase in the experience variable based on this age variable. So that kind of relation, that kind of variance I'm going to find with the help of some formula. So that kind of that method itself is basically a covariance, right? And the second point, it can take any values between minus infinity to plus infinity, right? It can fall anywhere, doesn't matter. So minus infinity to plus infinity, where the negative value represents the negative relationship, whereas a positive value represents the positive relationship. What does this mean? Let's take one more example. I'm going to say that this is a study hours, right? And here it is a marks. As and when I keep studying more and more number of hours, my marks are going to increase, right? In the final exam, if I'm studying 1 hour or 2 or 3, 4, 5, if I'm going to study on an average daily basis, 4 hours, maybe my marks in the final exam, I may get around 60, right? If I'm studying less, maybe my marks somewhere here, starting from 30, 40, 50, 60 up to 100. So if I'm going to increase my study hours, the chances of getting marks are higher and higher. So you see this, there is a relation. My marks are depending on the study hours. If the value is something like this, it is positively correlated, right? There is a positive relationship. So it's going to increase. It's a positive relationship, right? And if on x-axis, if I say that this number of hours basically related to spending hours on social platform like WhatsApp, Facebook, or Insta. If I am spending more hours on the social platforms, in that case, my marks going to be in a negative direction. Like 1, 2, 3, 4, these are the number of hours. If I keep on spending more number of hours on this type of platform, what is going to happen? So if I spend only 1 hour, maybe I will be able to achieve 90 marks, assuming that remaining hours you are going to study. But for the relaxation, for just to keep your mind free, or just to spend some time outside studying, you are just spending 1 hour. So remaining hours you are going to study. So in that case, you are going to get a 90 marks. But if you keep on spending more number of hours on these platforms, so what is going to happen? Your marks are going to reduce. If you're daily you are spending 8 hours or 10 hours on this social platform, obviously you will end up getting 10 marks maybe. So you see that it is starting from higher to the lower, that is negatively related. There is a negative relationship. Here we see this from minimum number to maximum. We are able to see that in that case it is a positive relationship, right? So that is what this point is talking about. It can fall anywhere between minus infinity to plus infinity. And the third point, it is used for the linear relationship between variables. So when we see this, so here we are, as I say, in this case, so as and when my number of study hours increasing, my marks also going to increase. So we usually use this covariance to find the relationship between two variables, right? So linear relationship. In that case, we will use this covariance. How much is going to increase? On this axis, if our data increases on x-axis or on this axis basically, right? So we use this for a linear relationship between variables. Study hours is also one of the variable, marks is also one of the variable. And the number 4, it gives the direction of relationship between variables. Yes, we have seen this positive direction and this is a negative direction, right? So it has the dimensions. Yes, it has the dimensions like numbers and things like that. We'll talk, right, in terms of study hours or spending hours on a social platform. So it has some dimensions, right? So again, it is like depending upon what type of variables you have. So we usually use those variables in order to find the variance between one variable versus another variable. All right. So if I want to present that, the covariance in terms of a formula, let's delete this. In terms of a formula, if I am considering an entire population, the whole population, in that case, I'm going to write, suppose covariance, okay? So I'm going to write summation of from I equal to 1 to n, where n is the maximum number of variations or the observations, and xi minus x dash, yi minus y dash, or you can say a mean. So this is simply nothing but a mean. So suppose say I have a x variable and a y variable. So I will also have a x bar and y bar. So assume this is a bar, right? X bar is basically mean of x, y bar is again mean of y. So I will have numbers here 2, 4, 5, 8. I will take a mean of these guys and I will write it here. That is basically my mean data. I will have only one mean for x. I will have one more mean for the y. So here let's say that 3, 5, 6, 9. I will have some mean number. So if I put that here, so it is basically, suppose let's say that 4 plus 2, 6, 6 plus 5, 11 plus 8, 19, 19 divided by 4, 4 point something, 4.7. Assume that 4.7. Okay, 4.7 is the mean for the x, and if I take here 5 plus 3, 8, 6, 14 plus 23, 23 by 4, 5.6. 5.6 is the mean. If I keep this, guys, in this formula, so xi is the very first point, 2 minus 4.7, right? Then it's obviously it's a plus, again 4 minus 4.7 plus 5 minus 4.7 plus of 8 minus 4.7. So that is for the x, right? And multiply. Now I'm going to take a y data. Similarly, I'm going to take 3 minus 5.6, 5 minus 5.6, 6 minus 5.6, 9 minus 5.6. So divided by n, number of observations. How many observations I have? 1, 2, 3, 4 divided by 4. Right? So if I'm going to, whatever the number I'm going to find, that is basically covariance of x and y. That is for the entire population. If I'm considering only for the sample, right? So we know what is sample and population. The only difference is n minus 1. Degrees of freedom, n minus 1. So basically n is the total observations minus 1. All right. So that is for the sample. So that's how I will be able to find the covariance between x and y, or two randomly selected variables. All right. Now let's move on and understand other concepts here. So as given here, so x and mean of given sample data, and x and y are individual sample of set that we have seen. Now again, let's understand covariance relationship. When I plot those data, as I already mentioned, so this is a negatively relation or large negative covariance. There is no variance, nearly zero variance. We don't see any direction here. So here a positive direction, large positive covariance, right? So that's how I can interpret. Now let's understand what is correlation. Let me take up this. So now what is the correlation? Correlation, it shows whether and how strongly pairs of variables are related to each other, right? So how strongly they are related? Like I have taken age and experience, right? If my age increases from 21 to 25, at the age of 21 I have experience 1, at the age of 25 my experience is going to be 5. Means that how much relation we have between these two variables, right? Age and experience. So is it directly related? If it is a directly related, means how strong they are, how strong relationship they are carrying, right? So that is what it is going to show, the correlation. So I can also say that experience and a salary here. So is my salary is depending on the experience. If my experience is 1, my salary is say that 25K. If my experience is 5, my salary is going to be 40K, right? How they are related? What is the bond between these two guys, experience versus salary, right? So how strongly these two pairs are related to each other. So that is what the correlation will tell us, right? Is it as and when my experience increases, is my salary increasing? or all the data points are lying very close to this best fit line. If they are very closely associated, then we can say that it's very strongly correlated. So that kind of relation, the correlation will be able to explain us, right? So it shows whether and how strongly pairs of variable are related to each other. First of all, it will find whether there is a relation or not. If there is a relation, and how strongly they are. So in this case, experience versus salary, they are very strongly related, right? So that is what this point says. Then a correlation takes values between -1 to +1, wherein values close to +1 represents strong positive, right? So if the relation is a +1, it always lies between -1 to +1. In between we have 0. As and when my percentage or my data increases towards right side, it means that that's much strong, there is a relation. If it is going this direction, there is a weak relationship. Then, and 0 is a neutral, there is no relationship. So +1 indicates a strong positive, and -1 represents strong negative correlation. Right? We have seen that study hours on a social platform versus marks, that's a strong negative correlation. Very simple, right? If you don't study at all, if you are spending whole your day playing or watching social sites, obviously you will not get time. Obviously your marks will go down, right? So that's basically a negative correlation. And in these variables are indirectly related to each other, right? Variables are indirectly related to each other, as the name itself says. It gives the direction and strength of relationship between variables. Yes, that point is covered over here and here as well. It is the scaled version of covariance, right? We have seen covariance, the formula and all. So based on that, we are able to find the correlation, right? It is a scaled version of covariance. As you can see that there is a association between correlation and covariance. They look same, but the names are a little different based on different scenario. And we have seen all the numbers, how they lies between what is the range and all. So there we have seen -infinity to +infinity. Here we can see it's lies between -1 to +1. But it is a dimensionless. Unlike covariance, it is a dimensionless. All right. And if you look into, let me remove this. If you look into the formula here, as you can see, correlation X and Y. So Xi we know, X bar, this is a mean. Y mean, we have Y. This is again summation from yi equal to 1 to n. And this problem we have solved. I mean to say that we have seen this formula in the covariance, same kind of a concept here as well. But in the denominator, basically, we have this kind of a square root formula, right? Xi minus X mean, yi minus Y mean whole square, and it is a square root. So this is basically a correlation, a formula. This is how I will be able to find the correlation of two variables, X and Y. All right. So if I look into graphics, or I would say graphs, let's look into this. As you can see, a positive correlation, this we have talked about, and there is zero relation, zero correlation. Data are randomly scattered here and there. There is no systematic pattern in this graph. And here we can see a negative correlation. It's more or less same as a covariance, but the formula we use to find the correlation and the formula we use for a covariance are little different.